Okay, today we're going to talk about combining like terms, and that's the I can statement. So 1.3, I can combine like terms. You've probably done some of this before, but as a warm-up, I'm just going to remind you, these problems right here are fair game for the quiz coming up. So I'm going to quickly go through these. Let's see. So we want to isolate that variable term 7y. So we're going to get rid of the -6. We're going to add 6 to this side. That's going to cancel from this side. We've got 14 over here. We've got 7y there. That's implied multiplication, 7 times y. So we want to undo multiplying by 7. So we're going to divide by 7. Those are going to cancel. We're going to have y on this side, and then 14 divided by 7. It does go in evenly, so we've got a 2 right there. If it didn't go in evenly, we'd stop thinking of it as a division problem and start thinking of it as a fraction. This problem right here has got that long fraction bar, so it groups these two together. So we want to get rid of that dividing by 5. So we're going to multiply this side by 5 and multiply this side by 5. We get a -15 on this side. We get an x plus 4 over here once those cancel each other off. So then we're going to subtract the 4 from both sides. We're going to get an x on this side, and we're going to get a -19 over there. Those should be pretty easy. If they're not, please make sure you get some help. Everybody's capable of doing this. It might just take a little bit of extra work. So now we're going to turn our attention to something else. We're going to turn our attention to things that could get a little bit more complicated, but we're going to try and make them as easy as possible. So we may run into an equation in the future that looks something like this ugly example right here. All right, and before we start solving it, we would want to clean it up. Well, the math way of saying clean it up is we're going to do something called combining like terms. Combining like terms is a type of simplifying an expression, or simplifying an equation, or simplifying sides. You may have heard it called collecting like terms. Either one's fine. Combining like terms, collecting like terms, either one of those is okay. Now, in case you've forgotten, terms are the individual parts of an algebraic expression, and they are separated by plus and minus signs. Plus and minus signs. Okay? So sometimes that might be a positive or a negative depending on how it's presented and things like that. So we'll see enough examples that you'll catch on to this, and we should be in good shape. So for example, I've got some terms right here. 5x is a term all by itself. That's a term. -3gh, that's a term. X is a term, -2abc is a term, and -7, every single one of those is a term. Now, if they've got a variable, there's a special name for the number that sits in front of the variable. I'm hoping that you remember what that is, and maybe you see it down below. The number that sits in front of a variable that's being multiplied by that, it's called a coefficient. So coefficient. And I've got that name written down here several times. So I've got these examples written again, and it says the variable term 5x has a coefficient of. Now, a lot of people will say, well, the coefficient is 5x. 5x is the entire term. The coefficient is just the number that's sitting out in front that's being multiplied by the variable. So the coefficient is 5. In the variable term -3gh, it has a coefficient of -3. Plain old x. You know what number's sitting in front there? It's understood to be a +1. So if we had an example like this, let's say I had a term of -y, then the coefficient on that one would be -1. So if there's nothing in front, it's assumed to be a +1. If there's a negative and then the variable, it's assumed that that number that's sitting out front, the coefficient there, is a -1. -2abc, that has a coefficient of -2, and then we've got this plain old number at the end. Plain old number like that, like -7 or 12 or whatever that plain old number is. If it does not have a variable on it, it is called I'm hoping you remember what this is, it's called a constant. Now, vocabulary is really important. We've talked about a bunch of different vocabulary over the last couple of days. We've got coefficient, we've got constant, we've got terms, combining, all that sort of stuff. If you don't know what the words mean, it can be really confusing. So it's important to know the difference between a coefficient, whoops, let me make space for that, coefficient, and a constant. Remember, a constant is just a plain old number. A coefficient is the number that's sitting in front of a variable. So if we do 5x, that means 5 times x. -3gh is -3 times gh. So let's talk about what like terms are. Like terms are terms that have the same variable, or I'm going to put s in parentheses. It could have the same variables. It's got to have the same set of letters behind it, and the same, I'm going to write exponent right here. Now, I'm going to cover that just because that's technically true. We're not going to deal with a lot of exponents right now, but it's a good thing to keep in mind because we are going to see those later on this year, and you will see a ton of those starting in 9th grade. We'll do a little bit this year and then a whole bunch in 9th grade when high school starts. So on example 1, take a look at the instructions. It's very specific. It says identify the terms of the expression and state whether the number in each term is a coefficient or a constant. Identify the terms of the expression and state whether the number in front is a term or each term is a coefficient or a constant. So I'm going to do this. That's one term. That's another term. Do a little squiggly here. That's another term. So I've got 3 terms right there. So this has a variable and that has a variable. So I'm going to say that these guys right here, 4 and -7, those are coefficients. And that 3 right there, 3 is and I'm just going to write constant right here. Okay. Next one, let's see, we've got a variable term right here. That's definitely going to be a constant. Okay, so I'm going to do a box right here. Now this one is also an x, so I'm going to do a little loopy line underneath right here. And that one is also a constant, so I'm going to do it like this. So we've got 4 different terms in this one. These 2 guys right here are variable terms, so we've got 4 and -3. And I'm going to try and write this correctly this time. Those are coefficients. And then these other numbers right here, the 6 and the 5, those are constants. 6 and 5, those are constants. Okay, so you've got to make sure you know the vocabulary. It sounds weird, sounds scary, but if you know the vocabulary, it's going to make things a heck of a lot easier. Okay, so we're going to take those 2 examples, transfer them down here, and then the instructions are going to change. The instructions here say simplify. Simplify is a way of saying, hey, we're going to clean this up, we're going to make this look as nice as we can. And now, before we get into doing these, I want to remind you that we usually write answers in alphabetical order. We always write them in alphabetical order, and usually with the constant at the end. So we write the plain old number at the very end. So we're going to go through here and we're going to take a look at this. We've got a 4x, we've got a 3, plain old 3, and then we've got a -7y. Well, none of those have the same variables and the same exponents. Definitely not the same variables here. So we're going to write them in this order. I'm going to go alphabetically. 4x, then I'm going to write the -7y, and then I'm going to write the +3. Now, all we did there is reorder things. We just made it look a little bit nicer. Alphabetical order, it's easier to correct, it's easier to spot, compare yours with a neighbor's or something like that. And then we've got the constant at the end. That's just a standard way of doing things, okay? So we'll take a look at the next one. So we've got the 4x, we've got the plain old 6, we've got the -3x, and then we've got the 5. So just like I did before, I'm going to do this. I'm going to put a little looping line underneath the 2 x terms, and then I'm going to put a little box underneath the 2 constants. That's going to remind me that I can combine those. So I'm going to do a 4x minus 3x. 4x minus 3x is an x. And then I'm going to lightly cross those off. That reminds me that I've already used those. So the only thing left is the 6 and the 5. I can combine those together. I end up with an 11. I circle that and then I've got my answer. Okay, now they're going to get a little bit longer, but shouldn't be too difficult. So let's go through here, and the first thing I want to notice is I've got some y's, some x's, some z's, another x, another y. So I'm going to do the x's first, and then I've got that constant right there. So I'm going to go through and I'm going to grab these guys right here. I'm going to put a box underneath those, and then I'm going to put a little looping line underneath the y's. I'm going to put a little zigzag line underneath this one, and then a plain old line on the -10. Those little symbols can kind of help me keep straight what I'm going to do here. So I'm going to combine the x's first. So I'm going to have -7x minus, remember that's a 1x, so this is -8x. I'm going to lightly cross those off. Don't cross them off and scribble them off so heavily that you can't see them anymore. We want to be able to double check our answers. We've got the x's done. Now we're going to do the y's. 9y plus 4y. I can combine those and I get 13y. Don't forget to put the positive there. so positive 13y. Now I've only got these two terms left, and I've got the z right here, so this is a 4z, and then I've got that negative 10. So I'm going to go ahead and circle that. I know I've got each thing taken care of. I can still see the original problem, and I know I got it right. Okay, let's take a look at the next one here. We've got some g's, an h, a couple of h's, and then some plain old numbers. So ABC, I have to run through the alphabet sometimes. So G is going to come first. So we're going to do these first. So we're going to put those together, and we're going to get a 4G. Let's lightly cross those off. Let's do the H's. I'll put some boxes underneath those. We've got to put those together. We've got 3 of them here. So I'm going to do something, a lot of people kind of like doing this. I'm going to put those together first because they have the same signs. Negative 1H minus 9H would be negative 10H. So we've got negative 10H and then plus 4H. That's going to give me negative 6H. So I'm going to put negative 6H right here. Lightly cross those off, remember. And then the only thing that I have left here is the negative 1 plus the 6. So that's going to be a positive 5. So I circle that, and I've got my answer right there. Okay, let's take a look at this one right here. Couple things going on this one. You'll notice that we've got some fractions, and we've got this term right here that has a k and a j. So these two with the plain old j's, those are like terms. These with the plain old k's, those are like terms. But this one right here, unless it has both a k and a j, we can't combine it with any of these other guys right here. So let's put the j's together first and then see if we have to use the calculator. Okay, so we've got a negative 14j and then a plus a 3j. That's going to be a negative 11j. Again, lightly cross those. Whoops, I grabbed the wrong one, didn't I? Let's see. Should be this guy right here. So negative 14j plus 5j. So that's going to be negative 9j. And then the k's, we're going to have the 3k minus 4/5 k. Now, if I change that, that's going to be, let's see, 2 1/5. I think that's going to be plus 11/5 k. Now, I did that in my head, and I did that by thinking of this in fifths. This would be 15/5 k, and then I put those together. Now, just to double check, we're going to grab the calculator and just make sure that we got that right. So I'm going to clear this off, and I'm going to do negative, and then remember the fraction input, alpha f1, okay? We're going to put that fraction in there, negative 4 on the top, 5 on the bottom, scoot over here, and then we're going to do the plus 3. Again, we can't put the variables in there. The calculator doesn't do that. We have to keep track of the variables for it. So we're going to put those in there, and we get 11/5. So there's our positive 11/5 k. So we're in good shape right there. And then we're just going to attach that 1/6 kj on the very end, and we're going to put it like that. Now, in the box right there, I've got a question that says, is there a rule about where to put terms with more than one variable? So that double variable right there, there's no good rule like there is for constants that we put the constants at the end, or that we generally put them in alphabetical order or something like that. There is no good rule for that. I kind of like putting it at the end. I think that's best. I think most people do that. So that's what we're going to do in this class. So let's take a look at the next one. Let's see, we've got some decimals right here, so that ought to be fun to work with, and we've got a double variable right there. So let's take a look at this. I'm going to combine the x terms together. 3.2x minus 3.6x, that's going to be negative 0.4x. Done with those guys right there. Again, feel free to double check me on the calculator. This xy term can't be combined with any of these others because it's got both of those variables. So all we can do here is write down the 2.5y, write down the 1.7xy, and then we're going to call it quits right there. That is the simplified answer. Some of these you can clean up a lot, some you can't clean up very much. Let's take a look at this last example. Let's see, right at the beginning of the alphabet, we'll do the a's first. So we've got a negative a plus an a. Negative a plus a is 0, so we don't have to write anything down for that. Those actually cancel each other off. Then we've got a negative b minus a b. So negative 1b minus 1b, that's going to be negative 2b. So we're done with those guys right there. And then the only thing left is the minus c, so we're going to put that there. And we don't have any constants on that one. Okay, hopefully that gives you a good reminder of how to combine and collect like terms. We've got a relatively quick worksheet. Again, if you've got questions, now's the time to ask. Please make sure you get it cleared up. Good luck on your assignment.